Hi everyone, this is SREE, Maths faculty in Talla Padmavathi International School. Today, let us discuss the exercise 3.2 of chapter 3 of class 6. So let us go to the first problem. What is the sum of any two numbers? That is, if you take two odd numbers, whether it is an even number or odd number. So let us see an example. Let us see here children, if I am going to take two odd numbers, that is 3 and 1. So if you add them, we are going to get 4, an even number. Next let us go with the 5, odd number, and 17, an odd number. So see here children, 17 plus 5 is 22. Again we are going to get an even number. This is an even number and this is also an even number. This is odd and odd. So see here, if you add two odd numbers, you are going to get an even number. So your answer is, if you take the sum of the two odd numbers, you are going to get an even number. Next. So what is the next one? B. So if you take two even numbers, let us take two even numbers, even plus even. That is 4 plus 6. So 4 plus 6 is what children? We are going to get 10. That is also an even number. Let us take one more. That is 15 plus 22. So both are even numbers. So add them. That is 72. So here also you got an even number. So when you add two odd numbers or when you add two even numbers, you are going to get an even number. Okay. Next, second way. State whether the following statements are true or false. The first one is, the sum of three consecutive odd numbers is even. The sum of the three odd numbers is even. Let us take three odd numbers. That is 5, 7 and 9. Now add them children. So 5 plus 7 is how much? 5 plus 7 is 12. So 12 plus 9 is 21. Is 21 is an even number? No, it is an odd number. So but here they have given that the sum of the three odd numbers is even. That means it is false. It is a odd number. So it is false. Next children. The sum of two odd numbers and one even number is even. So let us take now two odd numbers. Two odd numbers, okay, plus one even number. They are saying that it is even. Let us see. Let us take 3, 5 and here even unit is 6. So 3 plus 5 is 8. 8 plus 6 is 14. Yes, 4 is an even number. So what they have given is correct. The sum of the two odd numbers and even number is even. Yes, it is true. So we can write this as true. Okay. Next. The product of three odd numbers is odd. Now he is saying that the product of three odd numbers is odd, it seems. So let us go with that. 3, 5 and 7. So odd into odd is odd. Now see here, 3 5s are 15. So 15 7s are. What is 15 7s are? Yes, it is 105. Yes, it is an odd number. So see here, you got correct? Yes, it is an odd number. So what they have given is correct. The product of three odd numbers is odd. Yes, it is true. Next. If an even number is divided by 2, the quotient is always odd, it seems. Is it correct? So let us take an even number, that is 60. When it is divided by 2, the quotient we are going to get is what? The quotient is 8. Is 8 is an odd number? No, it is an even number. Suppose if we are going to take 14. 14 divided by 2 is 7. Yes, here it is 7. It is an odd number. But here we got an even number. But he is saying that the quotient is always odd. Is it always odd? No. Sometimes it will be even. Sometimes it will be odd. But we can't say that compulsory it is an odd number. So it is false. So the given statement is false. Next. All prime numbers are odd. Is all prime numbers are odd? Yes, the all prime numbers are odd. All the prime numbers are odd. It is true. Next, prime numbers. Next is all the prime numbers are odd. But see here children, there is a number 2. 2 is a prime number. Prime number where it is an even number also. So it is the one and only number which have that is 2. That is even prime number. It is even number and it is also a prime number. So we can't say that all prime numbers are odd. Why? Because here we have 2. 2 is an even number. So it is false. So it is false. Next, prime numbers do not have any factors. Do prime numbers do not have any factors? Prime numbers will have factors. Suppose 23 is a prime number. Now 23, the factors of 23 are what? 1 and itself. That means we have 2 factors. That means the given statement is false. They are saying that prime numbers do not have factors. So this is false. Prime numbers will have factors. But we have 2 factors, that is 1 and itself. So see here children, prime numbers do not have any factors. Prime numbers have factors. So that is false. Next. Sum of 2 prime numbers is always even. Let us take 2 prime numbers, that is 2 and 3. Is it always even? So this is a prime number and this is a prime number. Is it a prime number? Is it even always? The sum of 2 prime numbers is even? But no, we got odd. It may be even or it may be odd. So it is false. It is not always even. It is odd also. 2 is the only even prime number. Yes, 2 is the only even prime number. It is true. Next. All even numbers are composite numbers. All even numbers are composite numbers, children? No. Here we have number 2. Number 2 is an even number, but it is a prime number. It is not a composite number. So it is false. Except 2, remaining all even numbers are composite numbers, but 2 is included in that. So it becomes false. Next. The product of 2 even numbers is always even. Let us take 2 even numbers, that is 6 into 6. So 6 6 are 36. Or else we will take 6 fours. 6 fours are 24. Yes, it is an even number. Next, 8 into 4, 32. Yes, it is an even number. So the product of 2 even numbers is always an even number. So it is true. Okay children, by this we have completed the true or false bit. Now let us see the third problem. That is, the numbers 13 and 31 are prime numbers. Both these numbers have same digits, that is 1 and 3. Find such pairs of prime numbers up to 100. So see here children, I am going to give you examples of 2 and then you find still more. So see here, if I am going to take number 17. So if you reverse it, what you are going to get? You are going to get 71. So see here children, here both are prime numbers and it has same number of digits in it. Like that, we have 37 and 73. So see here children, 37 and 73. Both have the same digits, that is 3 and 7. But here both are prime numbers. So like this I have found 2 pairs find it. Next, fourth one. Write down separately the prime and composite numbers less than 20. So they are saying you to write prime numbers and composite numbers separately. That is less than 20. You need to write less than 20 prime numbers and less than 20 composite numbers. So see here children, I am going to write prime numbers here and composite numbers over here. So here 1. First we are going to take 1. 1 is a prime number or composite number? Yes, it is neither prime nor composites here. So we are not going to take 1. Next we are going to take 2, 3, 5, 7, 11, 13, 17 and 19. So these are the prime numbers less than 20, and next composite numbers 4, 6, 8, 9, 10, 12, 14, 15, 16 and 18 are the composite numbers less than 20. Okay. Next question is, what is the greatest prime number between 1 and 10? So first you should write the prime numbers between 1 and 10. So the prime numbers between 1 and 10 are 2, 3, 5, 7. Okay children. So in this, which is greatest? 7 is greatest. So you can write 7 is the greatest prime number between 1 to 10. Okay. Next, express the following as sum of two odd primes. So see here children, here they have given some numbers, that is 44, 36, 24, 18. So they are saying you to express the number such as the sum of two odd primes. It should be odd number and it should be a prime number. So see here, if I am going to take A1, that is 44. Here I can take the number 20. Oh, which number can I? 31. Shall I take 31? 31 plus 13. So just take 31 plus 13 is how much? That is 4 and 4. So 44. And here both are odd numbers and both are prime numbers. So as we have expressed the 44 as 31 plus 13. Next you try 36 and here I am going to talk about 24. So 24 we go with the 19. 19 plus how much? 5. So 19 plus 5 is how much? Just 14. And here you are going to get 24. So your answer is correct. That is, you can express it as 19 plus 5. The sum of 19 and 5. That is, both are odd prime numbers. So then you can get the sum as 24. Okay, next try 18. Next problem is, give 3 pairs of prime numbers whose difference is 2. So you need to take 2 prime numbers such that their difference should be 2. Like that, you need to take how many pairs? You need to take 3 pairs. Okay. The first pair I am going to consider is 3 and 5. That is 5 minus 3 will be 2. And next 5 and 7. So 7 minus 5 is 2 again. So yes, it is correct. Next I want to take 11, 13. That is 13 minus 11 is also, yes, 2. So here I took 3 pairs where the difference is 2. And see here children, 2 prime numbers whose difference is 2 are called as twin primes. So unfortunately we got that these are twin primes. We know that these are twin primes now. Why? Because the difference between the prime numbers is what? 2. So we can call them as twin primes. Next, which of the numbers are prime here? So see here, if you see 23, 23 is a prime number. 51, no, it is not a prime number. It's 37, and yes, it is a prime number. 26, 13 to the is 26. So it's a composite number. So what are prime numbers here? 23 and 37 are prime numbers. Okay. Next, children, write 7 consecutive composite numbers less than 100 so that there is no prime number in between them. So you need to write continuously 7 composite numbers such that there should not be any number in between them. So consecutive is nothing but what? Continuously. We need to get the continuous numbers. So here if you observe from 1 to 100 numbers, the prime numbers, and in between them the 7 consecutive numbers are 90, 91, 92, 93, 94, 95 and 96. So these are the 7 consecutive composite numbers less than 100 so that there is no prime number between them. What are the numbers? 90, 91, 92, 93, 94, 95 and 96. Now let us see 10th problem, that is express each of the following numbers as the sum of the 3 odd primes. So let us take your 21. 21 should be expressed as sum of 3 odd primes. So if I take 2 here, 2 plus 11, 2 plus 11 is how much now? 13. So 13, for 13 how much we need to add? If we add 8, then we are going to get 21. But here 8 is an even number. So you should not add 1, 8. Then we need to go for the other process. That is, suppose if you are going to take 3 here. 3 plus 11 is how much? 3 plus 11 is 14. So 14 plus 7 you do. Now you can give the answer. So 7 plus 4 is how much? That is 11. 1 plus 1 is 2. Now you got the answer. That is what? 3 plus 11 plus 7. So you can write 21 as 3 plus 11 plus 7. So we have represented, that is expressed the 21 as sum of 3 odd primes. Next, 11th problem. So remaining B, C, D is homework for you. Next, 11th problem. Write 5 pairs of prime numbers less than 20 whose sum is divisible by 5. You need to take the prime numbers less than 20 and you need to take sum of 2 numbers such that it should be divisible by 5. Like, first let us write the prime numbers 2, 3, 5 and 7. Next 11, 13, 17 and 19. So these are the prime numbers which are less than 20. Now you need to take 2 numbers such that it should be some pairs you need to take, 5 pairs you need to take, such that if you add them, it should be divisible by 5. So now check here, children. So 3 plus 17 is how much? Yes, it is 20. So 20 is divisible by 5. So this is one pair. And next like that you take the other pair. 13 and 2. So 2 comma 13, that is 15. So it is divisible by 5. Next, as they have given that 3 comma 7, and you can take your 11 and 19 children, that is 11 and 19. If you take 30 you will be getting, so 30 is divisible by 5. So 11 and 19. So one more pair you need to form. That is, if you see 13 and 17, so 13 plus 17 is again 30, so which is divisible by 5. So you got the 5 pairs. The 5 pairs are 3 comma 17, 2 comma 13, 3 comma 7, 11 comma 19 and 13 comma 17. So these all pairs, if you take sum of them, will be divisible by 5. Next, let us go to the 12th bit, that is fill in the blanks. Okay. A number which has only 2 factors is called what? The numbers which have only 2 factors. Yes, that is a prime. prime number. Prime number. Next, a number which has more than 2 factors. Yes, that is composite number. It is called as composite number. The numbers which have more than 2 factors are called composite numbers. 1 is neither prime nor composite. Very good. Next, the smallest prime number is, the smallest prime number is 2. The smallest composite number is, it is 4. The smallest composite number is 4. Next, the smallest even number is, what? Yes, it is 2. The smallest even number is 2. By this, we have completed the exercise 3.2. Thank you. This is B.VIDYA from Talla, Padmavathi.